and welcome to the Serverless Basic course. I'm so happy that you're here, and this course is something I created with my past self in mind. Around the spring of 2016, I started learning serverless. I had to fix some problems, and serverless was something that was coming out. There was a lot of buzz, but there was really little material. So I thought, what I can do to solve that problem, create a small course that will provide the bare basics that you need to get started and to continue your education. So in this course, you will learn the basic things that you need to know on serverless. You will create your AWS account, you will secure it, we will start learning what is serverless and when to use it and what it is and how to get started with serverless framework. Then we will get started launching our Lambdas and API gateways and working with Dynamo. So it's a very short, practical course. There's a lot of exercises, and I hope you code along me when we are working in this course, because everything is for you to practice. All the code is available in GitHub, so you can find the links in the course after each of these lectures that have code. So you should go and really practice. There are also assignments. There are 2 big assignments that you need to do all in your hands, so I will not be coding alone, but the solution is available in GitHub as well, so you can find the answers if you get stuck. And if you're stuck, don't forget to ask any questions you have in the forum of this course. I want to answer your questions, and if you have things that you really don't know where to start or things about serverless that are not covered in this topic, also ask them in the forum. I want to know more about your thoughts and what you are interested in watching. So in this first unit, we are going to get started creating our AWS account, learning what is AWS and what is cloud, and then we are going to move forward in the serverless journey. So grab a cup of coffee and let's get started. I'm Marcia Villalba. I will be your instructor for this course. I'm an AWS serverless hero, and I'm a serverless champion from the serverless framework guys. I'm also the host of one of the biggest, I would say the biggest YouTube channel about serverless called Fubar. You can find the link in the screen and in the related links. And there I post videos about serverless and free material. I'm also very active in Twitter, where you can also follow me to find what I'm doing right now. And I've been working with serverless already for over 2.5 years. So for the serverless time is quite long. I have worked in production environments with lots of users and lots of use cases. I have migrated services to serverless. I have worked on clean slate projects. So there is quite a lot of experience I have on working with serverless, and I hope I can transfer that to you. So I hope that you enjoy my course. Ciao, ciao! So this video is about what is cloud computing and what is AWS. To understand what cloud computing is, we need to go and see some history. So let's go to it. In the past, all the companies were owning their data centers. Companies have their computing power in their basements, and they own the computer-powered machines. So if they need to scale their systems, they need to buy more computers or bigger ones. With time, virtualization came in place, and companies start to use it to share the computing resources between different products, and later between different companies. Sometime later, specific companies started selling hosting services for these companies that they were producing products. They were offering computing power and storage capability. They were offering that these resources were shared between different companies, and those companies were not the owners of these resources. So if the company needed more computing power, they just need to ask for more computing from their provider, and it will just scale up. This was the birth of the cloud providers. Those companies that they were providing computing power and storage solutions were the first public cloud. Nowadays, cloud providers not only provide basic infrastructure, but all kinds of services and software on top of that infrastructure. So what is cloud computing? It's the use of computing resources, hardware and software that are delivered as a service over the internet or a network. You don't need to have it in your own premises. What are the characteristics of a cloud provider? It's reliable. You don't need to maintain the infrastructure. It's cost effective. You pay for as much as you use. It's scalable, you can scale it up and down, and it takes advantage of the economics of scale. Cloud providers provide lots of different services, not only hardware, services that can be integrated into your applications or can be used as end applications. AWS, Amazon Web Services, is a cloud provider. AWS provides a massive global infrastructure that allows companies to innovate, experiment, and iterate. Some of the characteristics of AWS are: it's on demand, use it when you need it. It's uniform. Because of the economic of scales of AWS, customers can leverage the cost-effectiveness, scalability, and flexibility of running AWS infrastructure. You pay as you go, no pay in advance. There is no contract. It's available. AWS is available by the console, the SDK, command line, and API. Let's talk about AWS services in a little bit more detail. AWS provides infrastructure. We are going to talk a little bit more about this in a moment, but these are the regions, availability zones, and edge locations. Also, it provides what it's called foundation services, that is computing, like EC2s and Lambdas. EC2s are the virtual machines from AWS, and Lambdas are the functions as service. It provides some networking capabilities like VPCs, that is a private network that you can build inside AWS, and CloudFront, that is the content delivery network from AWS. It provides a storage service like S3, that is a place where you can store files, and they have others different as well. And also admin capabilities and security like your IAM, that is where you create your users, your security roles, and your policies, and CloudWatch, that is a place that it has the unified way that you can check logs and monitor different services from your AWS. These are the basic services that you can use directly or that the platform will be using. And then on top of that, we have the platform services. The platform services are managed services by AWS that you can use in your application directly or as a standalone service. For example, we have DynamoDB, that is the NoSQL database from AWS. Then we have Kinesis, that is stream service for stream events. Cognito, that is the authentication and authorization managed service from AWS. CloudFormation, that is the service that you can use to build and manage your infrastructure as code. API Gateway, that is a service you can use to manage your REST endpoints. And there is so many of these. There is I can fill many pages of platform services, and I think that's where AWS is growing and growing and growing nowadays. These are just some examples. Let's go back to the infrastructure and talk a little bit about the global infrastructure of AWS. That is, I think, one very important characteristic. AWS has infrastructure all around the world. There are 18 data centers globally nowadays. These are called regions. By being globally distributed, it's possible to achieve lower latency and higher throughput. Also, AWS has a lot of CDNs, content distribution networks. These help to reduce the cost of transfer data, latency, and performance to end users. So let's go back to what is a region. A region is where the data center is. Each region has at least 2 data centers. In AWS terms, they are called availability zones. This is done to provide redundancy in case of something happens. So if there is one, explosion or something goes like out of electricity or flood or something happens, that's why you need 2 or more. These availability zones are connected with high-speed internet, but they are isolated from each other. So they use different network companies and different parts of the city. From outside, this availability zone seems like one data center. So in few cases, you will know in which availability zone your service is being hosted. AWS services run in these regions. Most of the AWS services are region specific. So when you create a new service, it's good to pick a region that is close to your customers. So let's put everything into an example app. Imagine you're building your own Twitter-like service. The first thing you want to do is to pick a region for all the available regions. You choose Ireland as most of your customers will be in Europe. Then you create the web page and place all the statics files in S3 buckets that we use CrossFont as the content distribution network, so the files will reach your customers faster. For managing your backend, you choose API Gateway for your endpoints and AWS Lambda for your computing. You also need a database to keep track of users, tweets, and other information of your application, so for that you use DynamoDB. You said users? You need some way to authenticate your users to your system, so for that you use Cognito. Cognito will give you users temporary IAM permissions into your AWS account to perform different actions. All infrastructure is created as code and is built and deployed using CloudFormation. And you can check the logs of your application with CloudWatch. This is a serverless application. There are no servers and the system scales up as you need, and you also pay as you go. In this video, I want to show you how to create a secure AWS account. I will show you the steps that you need to follow in order to have it secure. We won't be creating one account, we will be creating two. So how AWS works is that you will have your root account, that is the one that you will create with your credit card and all that stuff. And that will be like the master of the universe account that will have access to all the services, super admin rights. But you don't want to use that account. You don't want to give programmatic access to applications to access that account. You don't want to use that account in general, because that account has a lot of privileges and you cannot revoke the privilege. So if somebody hack into your account, they change the password, then you are locked out. So what you want to do is you have a very secure root account. We'll be creating a user with admin rights in that account, and then we will be using that account for everything else. And that secondary account will be also very secure. We are going to secure everything with two-factor authentication, so you will need to download some app for your phone. It can be Google Authenticator or others. For doing this, you will need also a credit card, because AWS will require you a credit card. And you will need also a phone that can receive calls, because they need to validate that you're a real person. They will call you. So let's go to the code. So the first thing we want to do when creating an account is to go to the AWS page. You can explore there all the different products they have, and also you can go to the pricing tab, and there you can see all the information that you will get when you register an AWS account. You have the free tier, and some services are free for 12 months, services are always free, so you can go and check them out. After you have checked that, then you can go and press the button create an AWS account, and we can get started. Let's follow the steps to create a new AWS account. You just put your email. I will block everything with a gray thingy so you don't see all my information, and then you put I'm a new user, and then you can just sign in. You type your name, your email address again, and then you put a very secure password. This is the root account, as I mentioned before, so we want to have a very secure password. Even though we are going to use two-factor authentication, we want to have a secure password here. Then you need to fill your contact information. You can pick if you're a company or you're a person, and I will be picking a person, and I will be filling this up with my contact information. Then you put the security check. Sometimes that security check is tricky, but just try to fill it up, and you continue. Then you put your credit card information, and you can continue as well. The identity verification step is the tricky step, because here you will need to provide your telephone number, and that sometimes doesn't work. If you're in the US, I heard it works very well, but if you're outside the US, there is some problem. The bot might call you and the PIN might not work, or the bot might never call you, and then you're waiting there for a while. But if this doesn't work, then you will get a message that says that you need to contact them. And there, if you click that contact box, then it will open a page where you can check if you want to chat with someone. And they usually have 24/7 chat. You can start chatting with a human, and that human will ask you for your phone number, and they will call you. And when they call you, they will ask you for some information to verify that you are you, and then they will do all this process automatically. So if you cannot get the bot to call you, don't worry, there is always a human that can call you. If you manage to get the call from the bot, you need to input this PIN number, or the PIN number will change. After that succeed, then you will be moving to the support plan page, and we will pick the basic, that is the free support, no help whatsoever. Basically just the forums and other billing questions and things like that. But then we pick that one and we continue. After that, we just can launch the management console. We have done all the steps. We have our root account, and we can get started to securing. After that, we just can launch the management console. We have done all the steps. We have our root account, and we can get started to securing it. The first thing we are going to do is to go to IAM, and IAM is the Identity and Access Managed Service from AWS, and there they will show us that we have 5 steps to complete to make our AWS account secure. The first step is done for us already, that is delete your root access keys, meaning that you cannot access programmatically this account. The next step is to activate the two-factor authentication in your root account. For that, you will need to have installed some application in your phone, either Google Authenticator or others, to get you one-time passwords. Here, if you click a virtual MFA device, if you have a phone, then you click next, and in this step it will show you in the here, that is blue and a little bit linky. If you click there, it will show you what other applications are AWS MFA compatible, like Google Authenticator, but there are others, so just go there and check if you have not installed any, or if you have one and you want to make sure that it works. After you have installed the application, then you can click next, and here just go to your application, scan this barcode, and put your 2 consecutive authentication codes. You might need to wait 60 seconds for the codes to refresh. At least that's what happens in Google Authenticator. And now every time you want to log into your root account, you will need to put your password and your one-time password from your phone application. One thing you can do also from here is to change the URL where users used to sign in. You will have a specific URL that is the account number plus some stuff, but if you can change it to something more user-friendly, I will put learning serverless, but you can use anything you want. So after you have done that, then you can go and create your first user. This I will have an admin user, but I won't assign any permissions to it. I will just make it flat. So you have student 1 and you want to give them programmatic access to it, that is the SDKs or APIs access, and then you want to give management console access, that is username and password. So when the user logs in for the first time, it will need to change the password. And I will add users to a group later. So now we just click next. We have a user without any permissions. This page is very important. Here it will show us the secret key and the password for this user and the access key for this user. So there is this CSV file that you can download. You should save securely because you will need it whenever you are logging for the first time to the admin console that will ask you for this password, or whenever you are configuring the programmatic access for this user, for example, when we are setting up serverless framework. These keys won't be displayed again, so you will need to regenerate them. So it's good that you keep them safe in some place that you can access them whenever you need. After you close this page, you don't have access more to download this file. Download it, keep it safe, and then you can continue. The next step we want to do is to go back to the dashboard and create a group. These groups, we are managing the permissions in a group-based permissions, so the groups will have the permissions and users will get assigned to those groups. So then it's easier to just remove the user from the group and the user will have no permissions whatsoever. This makes the whole administration more secure. It's a good practice that you have the permissions in the group level. So I will just manage groups and create a new group, and I will put the name admins, and I will be giving the policy of administrator. And then I can create the group. You can make as many groups as you want, as fine-grained as you want. And then there you can add users to that group. We only have one user, that is the student 1, and it's added there. And the last step is to apply a policy, a password policy, whenever the user will sign in to the console. That I like to make it a little bit complicated, so the passwords are not just admin, they can be something more. And I apply that password policy. We copy the URL from this that we change, the signing URL, and then we will log out from this account and we will not come back ever. There is no need to come back, maybe for some billing stuff, but besides that there is no need to come back. We can paste in our browser that URL, that signing URL, and give enter, and we will log in with our user student 1 that we just created. We put the password that was in the CSV file and we log in, and then the first thing it will ask is that we want to change that password. We should put a secure password again because this is an admin user, it has access to everything. Now we go back to the IAM and we will give a two-factor authentication to this user as it's an admin user, and we don't want nobody to steal our passwords and be able to start abusing from our services. Even now, if somebody steals this account, it's not that big issue because we are still in control of our root account, so we can go there and we can basically remove this user from the group, or we can even delete this user. So we are doing exactly the same steps that we did before. We are assigning an MFA, a virtual MFA device to this account, and we are configuring it with, in my case, Google Authenticator. And just put the 2 authentication codes, scan the barcode, and ta-da, now it's associated. And now this account, whenever I want to log in, I need to have the console login link, the username, the password, and the 2-factor authentication. Now you have a very secure AWS account for all your projects. So today I want to talk why serverless is a really cool tool, I don't know, software engineering technique or whatever it is for empowering developers. I get asked a lot about why serverless, but in general it's always about the company perspective, and I think we already have heard about the company perspective a lot of times why you should choose serverless, and usually when you check those lists of why serverless over other architectures, you always end up with the companies. Also, I think it's important to acknowledge why developers should learn it, why developers care about it, because at the end of the day, those are the persons that are making the tools and making the software. So first we need to convince developers, and then we can go to companies. So the first question to ask is why you're interested in learning this. So maybe to start that, we should go one step backwards and answer the question, what is serverless? I'm sure you already heard it a million times, but it will be brief. So serverless is computing execution as an utility. So it's like the water tap at your house. You just drink it, you flush your toilet, you wash your clothes, you use it to solve different problems that you have at your house, but you really don't care how your building have structured the pipes and how the city managed to deliver the water from the central water tower to your house, and you don't care how the country gets that water and how it comes to you. You don't care about the infrastructure about the water. You care that it's just there and you can drink it whenever you need it. And one thing about water or other utility is that you just pay as much as you use. So if one day it's hot and you want to water all your garden, you will pay quite a lot of water because you fill your pool, you water your garden. It's very hot summer day. So yeah, but then maybe you went on holidays and you didn't spend anything, no water used because there was no one at home, and then your bill of water is close to zero. Same happens with electricity and other utilities. And the idea behind serverless is similar, is to have computing execution as an utility. So you can use it as much as you want. It can be scale. So if you need to fill pools of computing power, you are able to. And you don't care how your provider of computing power solves that problem for you. But if some months you are on holidays and you don't want to have any computing power, you just don't pay for it. So to summarize, serverless is computing power as an utility. It can scale automatically and you pay as much as you use. So why you care about learning this? Why you care? That's a valid question, and you should ask it all the time before starting to learn something. There's so many technologies around, and it's hard to decide which ones you should choose. And so first, I will give my answer to server developers. If you're a server developer, serverless is the next thing. After containers, I'm sure you learned Docker a couple of years ago. Now it's time to learn serverless. It's just how the evolution goes. If you want to keep on the trend and you want to have a cool job for the future, you should learn this. So, sorry, man. But if you're a client developer, then the story becomes a little bit different, because your main job is not to produce server. So why you should care if you're a web developer or an Android developer, iOS developer, game developer, all these client-facing developers that are not working in the server, why they care about learning serverless? And I think my first answer is, if you're a client developer and you learn serverless, you will become way free. Yes, free. How you become free as a developer? Because I think it's a very easy, fast step to become a full stack developer. And I'm not meaning with this that server developers will be like discarded and we don't need them anymore. No. I'm meaning that now as a game developer or a web developer, you're able to solve some problems that are pretty simple without the need of asking another developer for help. So if you're at home doing side project, or you have a small company, or you have a project with little people, then you can be more independent and solve more problems. So you can create a small server that connects to a database and returns something, or that processes some data or resizes some image, or you are able to get done a lot of things with very little knowledge. Because if you're a web developer, you might already know JavaScript very well. So it's just about learning some tools to work in the serverless world. If you're a game developer, maybe you're using C#, so you can also go to .NET and start working with serverless. So there is quite easy steps in order to get started. And I think serverless is a really good way to get started with the cloud, because I think the whole, at least in AWS, the whole serverless landscape has been done with the mentality that people don't need to be experts to get started. So getting started with these tools is way easier than to get started with instances and VPCs and all that kind of older stuff. If you want to get started with cloud, if you want to be more independent, if you want to become a full stack developer, you should learn serverless. So what I'm going to do in these videos, first I'm going to show you which terminal I'm using, then I will be installing some packages that you need in order to install serverless, and also I will install Atom, that is my default text editor. So now let's go to the computer screen and let's get this rolling. So now I'm in the computer, and the first thing I want to do is to install the terminal I like to use, because in Mac I don't like the Mac terminal. So I will install this iTerm2, and for that I'm going to the web page where iTerm is, and I just download it, and then I run the installation process as any other Mac package. After it's done, then we can go and install Node. We just type brew install Node, and as easy as that, Node comes and it's installed. Brew works for a lot of different libraries that you might need, so you will enjoy using it for other things as well. And this will download the latest version of Node into my computer. After it's done, then we are ready to install serverless. Serverless is a Node library, so we will going to install it as a global package in our computer. So we just do npm install -g serverless, and we download serverless package in our computer as a global library that we can use from anywhere. When that's done, then we are going to configure our credentials, our AWS credentials, in the serverless package that we just downloaded. And for that you need to have an AWS account. So we follow the instructions that are in the serverless page, that is to set up your provider credentials. And for that there is a lot of information that you can follow, or we just can do one magic line. That is the line that we want to use to configure our credentials, serverless config credentials, then the provider and the secret. To find the credentials, you need to go to your AWS account that you created, go to IAM, and then go to your user, security credentials, and you can create a new access key. You follow the video that I recommended, you might have already the CSV file downloaded, so you can just open that and you don't need to do this step. When you open that file, you will see that there is an API key and a secret, so you just need to put that in the line. And in this case, I will just do serverless config credentials providers, and that's all. Then if you open your file, the AWS credentials, then you will see that the credential is configured there. So now that I convince you, I will show you some steps to get started. So let's go to the screen and let's go to it. Now you're ready to go to your terminal, create a new directory. I will call it first serverless project. You can call it whatever you want. I will get inside that directory, and then I will create my first serverless project. That is pretty straightforward. SLS create, that's just template, AWS Node.js, that's just name, and the name of the project. So this is the easiest way to create a new serverless project. You just do SLS, that is serverless, that is what you just have installed. serverless framework, create, to create the project. You pass the template name. In this case, we are going to use AWS as our cloud and Node.js as our framework, and then the name of the project that we will need. It's pretty straightforward. Just press enter and serverless framework will generate some files for you. Then I always do npm init-yes because that creates a empty package JSON. So if I need dependencies or something, I will put them there. After that, I open this in Atom, and you can see that we have 3 files. First one is the handler.js, package JSON, and serverless YAML. Let's visit the serverless YAML first. The serverless YAML is the file where all the serverless framework configuration is. So this is a file specific for the serverless framework. Here you will define the service name. That is the name that we just put when we created the project. The provider and the runtime that's come from the template. In this case is AWS and the Node.js 6.10. And then you will also define all the resources, AWS resources, including the Lambdas and the API gateway. So if you scroll down, the template already has one Lambda function called hello that is managed with the handler code that is in the file handler and in the method hello. We are going to go there in a second. But if we want to define an API gateway, that is the front door to our Lambda, that is the endpoint, we just do this. Events, then we put HTTP because this will be triggered by an HTTP event, that is the path hello, and in the method get. So easy like that, we create a new endpoint that will trigger this piece of code. It's very, very simple. Then we can go check this package JSON that doesn't have anything interesting for now. And there you have the handler.js that has the information, has the code on how to run this Lambda. And here is a very simple hello method that comes out from the template. And the only thing you will see is an object response and a callback that is returning that response. We are going to modify that response object to just change the message. Hello and congrats on your first serverless project. So you can see that we are deploying the right project. And then this body will include also an event. That is the event that comes from the handler. So usually in the handlers you have 3 parameters, the event, the context, and the callback. The event is the information the Lambda is getting from the trigger, in this case from the API gateway, and you will be able to see it in the body. And the response is a 200 status code. So then when we save this and we go back to our terminal, we can run SLS deploy. That means serverless deploy. So this is deploying this project into AWS because we have configured the credentials from serverless framework. Your AWS credentials into serverless framework. It's possible to just with a small command put all this project into your cloud. Serverless framework will package this and then deploy it. Serverless framework is using CloudFormation, but you don't need to know what is going on in the background to understand what is going on at the beginning. So I will speed this up because usually this takes a couple of minutes and you cannot do anything. After the deployment is complete, you will see this service information that will show you the service name, the stage. We have not defined the stage, but serverless framework by default, if you don't define the stage, will put it to stage dev. You can have any name if you defined it. Same with the region. If you don't define any region, it will just deploy US East 1, that is North Virginia. You can put in the AWS region that you like. The stack name, that's the CloudFormation name of the stack that you don't need to know for now. We don't have any API keys. We have one endpoint, that is that one, and one function that is also there. And then if we grab the endpoint, that URL, and we paste it in our browser, we can call the Lambda. You see that the endpoint is a get in the path hello. So if we put it in the browser, we will see that there is the message, hello, congrats on your first serverless project, and then the input, that is all the event that this Lambda is getting from the API gateway. API Gateway is a fully managed service from AWS that lets you manage, create, delete, control, monitor, and do all kinds of things with your APIs. So it's pretty straightforward. So an API is like the front door to your application. So API Gateway lets you manage this and have control on it and monitor it and create security on it, so not everybody can get through. And you can do traffic management to know how many requests you're going to let through and how often and things like that. So API Gateway and Lambda are a great team, because whenever you can do like a request and Lambda will be executing it, then you don't need any servers. You can have your web backend working with APIs totally RESTful without any servers. And I think for me that was one of the moments I realized that serverless was super powerful. So when you combine AWS Lambda and API Gateway, you have a very powerful combination where Lambda provides the execution, API Gateway provides the access. So whenever a request comes into API Gateway, that request will trigger the Lambda will do the processing and respond back to the API Gateway, so the user or the service that created the request can see the result. The advantage of having this is pretty straightforward. You can have the API Gateway and you can have a Lambda, you can replace that Lambda with another Lambda, and the API Gateway is still the same. So all the clients that were connected to that API Gateway, they don't need to know about the Lambda that is behind doors. So it's a great way for distributed systems, so you can replace parts without really altering the whole system. So while you keep the URL that API Gateway is offering, then it doesn't matter what is behind it. So that's why it's called a front door. So as with any other triggers, whenever API Gateway triggers Lambda, you will see an object event, and it's a different type of object event that you will see with Dynamo Streams or with SQS or with Kinesis. So it's a different one. In this event object, you will see if there is any query parameters, if there is path parameters, if there is something in the body, if there is a post, for example, or which kind of HTTP method we are calling, or which kind of headers, like HTTP headers we have. So you can find all this information just by looking inside the event object. So Lambda can access this information and you in the Lambda can work with it. So now let's go to the code and play a little bit, creating different types of API gateways and seeing how they work. So let's go to the code and get started. We are going to create a new project, serverless framework project, using, as always, creation, like creating a new directory and using the SLS create -- template, AWS Node.js, and the name of the project that is the same as the folder. So when we have that, then we can get into using Atom or your favorite text editor. The first thing we are going to do is to clean a little bit the serverless YAML so we can see what we are doing. As always, the code, you can find it in GitHub, so you can run it yourself. Then I will change the runtime to 8.10 and I will add my profile, that is student 1. If you don't have many profiles, you might have default, so you don't need to add this line. Then you can save and we can get started by adding an event to our function hello. So when we add an event, in this case it's an HTTP, it's an API Gateway event that will trigger this Lambda, and it will trigger it whenever we have an HTTP with the method get in the path hello. So when we deploy, we will get an HTTP endpoint with this characteristic. So now we go to the handler, and there we can see the events object. If we do the console log, we can see it there, or we will see it also in the response because we are passing it there. So we will analyze it, and I can change the message so you know that this was deployed. So I will call API Gateway was called. Whatever you can put there, this is just a test. So now we deploy. I will speed this up so we get fast to the part that we are interested in. So when you finish the deployment, you will see that you have an URL that it says get, and it has the URL. So that's what we need to run in Postman. Postman is the tool that I'm using to run these HTTP calls, but you can use any other that you like. You can use curl or whatever you feel comfortable with. So this is the most simple example that we can have with API Gateway. So I put the URL that I get from the information and I send this request, and I can see the message, the API Gateway was called, and then I can see the input that's the whole event object that API Gateway is sending to Lambda. So we can take a look at that, and we can see that there is a lot of information there. The first thing we can see is the resource that is \hello and the path. Then we can see the HTTP method that is get. Then we can see all the headers that API Gateway is sending and the ones that CloudFront is putting in front. Then we have query string parameters that is null, path parameters that is null, stage variables that is null. Then a lot of information about the request, about the context of the request, and then we have the body. If we pass a query parameter, then we will see that everything stays the same, but if we check the query string parameters, we can see now that there is that one that we just added. If we want to pass a path parameter, we need to do a new endpoint because this is just not existent, so we get an error. We can pass a header, so if you test header and then we put hola, then we can check that in the headers there is this test header hola there, so that's how you can pass information through the headers. Now we can modify our existing Lambda to accept a query string parameter and send different message depending if there is a parameter or not in the query string parameter. So we do this by doing event.queryString parameter, and there we can find .name, that's the name we are looking for, that's the name of the parameter, and then we just change a little bit the logic. So whenever we have something in the name, then we change the message to hello, whatever the name was, and if not, we don't have anything, then we just say hello world. So we can deploy this and see how it works. After it's deployed, we just run the same URL. Now we put the query string parameters and we will see that it says hello Marcia. If we remove the query string parameters, we will see hello world. And we can also see in the event object that we have the query string parameters. So now we create another Lambda and another API gateway that we'll call Moi. It's hello in Finnish, so I'm very original. And in this one, we are going to pass a path parameter. So for doing that, we need to put in path / and then curly brackets name, that is the name of the parameter we are interested. So we are going to our handler now, and we are going to create a handler method for this Lambda. So it's basically the same as in the previous one. So instead of doing query string parameters, we are going to do event.pathParameters.name, that is the name of the parameter we are interested, and then we can keep the same logic. It just doesn't matter, but it should show hello and the name when we deploy. Then we can deploy and speed this up, and then we will see when this is completed that we get a new endpoint. And it's also a get, and it has this URL, and it's moi / and the name. So we can open that in Postman, and we can pass a name, and we send it, and we see that it's hello Marcia, and then the resource change now, and we have path parameters that is name Marcia. Now we can create another Lambda and another API gateway with a post, with a body, and we can create it called hola, hello in Spanish, and it's as simple as just changing the method to post, and now we have a post endpoint, and we can create a new handler method that is called hola, and here we are just grabbing the body that you can find it in the event, and we are doing a parser of JSON because the body is just text, so we want to get it in the JSON format, but you can do this if you're passing JSON. If not, then you need to do something else. So basically we just return the body in the message so we can see it. It's very straightforward, and then we can deploy this and test it out. So after we deploy, we will see that we have another endpoint. This time is a post with another URL that we can try in Postman. And let's go and try it out, and remember to change the HTTP method to post and add something in the body. In Postman it's a raw, JSON is the content type. So we write name, and then we put my name, and then we can send this, and we can see that the body is in there as a JSON. Oh, now we can pass something else because this is very free format. So we can see that it appears there. And then if we go down and we look for the body in the event object, then we will see that it's just a string. That's why we need to parse it. Do you trust me that the previous things are running and working? Are you sure? How you know? In this section, we are going to tackle monitoring. Monitoring is very important to know what is going on in your system and how the different parts of your system are working. And when you are working in a distributed system like serverless it's very critical to know where to find the information on the different behaviors of your different parts of your service. So that's what we are going to learn next. I want to start from the very start, asking the question, what is CloudWatch? CloudWatch is the monitoring service from AWS. It helps you to keep your logs, track some metrics, trigger some alarms. It can also record all the different changes in your infrastructure, so you can do things with it, like trigger lambdas if you have too many instances running or things like that. It does all kind of very interesting things, so it's more than just a login tool. So CloudWatch helps you to bring the visibility from your infrastructure into one place. That I think that's one of the biggest challenges in AWS, to see what is going on in all these different services, and CloudWatch is that place where you can connect everything together. We have been using CloudWatch to check the logs from Lambdas, but you can also do other things with it, like check different metrics in your Dynamo, or even check the logs from the API gateway. If you enable all resources, will push some kind of information to CloudWatch. But specifically for Lambda, CloudWatch is a great thing, because when you have this execution times that is very limited and ephemeral, and you want to respond as fast as possible, you want that your login is not consuming kind of your execution time. And when you're working with Lambda and CloudWatch, Lambda will be kind of streaming asynchronously the logs to CloudWatch, and it doesn't consume any extra execution time in your function, and it doesn't generate any performance issue as with other libraries, external libraries from AWS, that might generate some problems. So that's why usually it's a good practice to use your CloudWatch for logging in Lambda, and then maybe use some external library to see these logs or filter these logs or something like that. But keep the CloudWatch as the login place for your Lambda. So now I want to show you basics of CloudWatch. Let's go to try out the metrics, the login and the dashboards, and let's go to the console to get that done. Let's start by creating a new empty project. This is going to be a very simple project, so just follow the steps as always to create a simple project with AWS Node.js as the template. We are going to get into Atom and do some small modifications. The code is available in GitHub, but this is very simple code, so I just remove all these comments to make it simpler to read. And then I will create a trigger for the hello function, so we can trigger this easily. What we are going to do here, after we create a trigger, is to do a console log, because that's what we want to try. I will just change the message to something, and this console log will just write hello in the console, hello was called. So very simple message. So we will deploy now, and we will see what happens. So I will speed up the deployment, and when we finish deployment, I will just trigger this function with that URL. I'll just trigger it from Postman, and we can see the message. So now we can go to Lambda in our account in AWS in the console, and then if you go there and you look for the function that you just deploy, the CloudWatch dev hello, you can go to monitoring, and there you can see the different metrics for this function. And to see the logs, you can just go to logs. This is one way to find the logs, and there you can see the logs for this call, and you can see hello was called. Another way is a little bit more straightforward, but in a way not that easy sometimes to find, is to go directly to CloudWatch and then go to log, and there look for the logs in the list of lambdas. If you have few lambdas, then it becomes very easy. If you have a lot, like me, this becomes very painful. So when you find your lambda, then you can get into the log group, and then you can see exactly the same. Another way to do that to see the logs, my favorite, I will say, is to see the logs from the serverless framework in your terminal. So you just type SLS logs -f, the name of the function, and -t to tail the logs. So this, if you keep on calling, it will keep on appearing. If you don't put the -t, it will just print whatever is there. Another thing you can do with CloudWatch, as I said, is to create dashboards with metrics. So I will just create a new dashboard. I'll put the name Testing CloudWatch. You can put any name you want. And there you have an empty dashboard, and there you can add widgets. So these dashboards you can display in a screen, or you can have them open to see how your service is performing. And when you add a new metric, you can look for the different services. So we will just look for Lambda, and then you can look by function name. And there is all the functions there. And I will just look for the serverless CloudWatch, and you can search, so it becomes easier. If you put the name of the function, it just shows that, it filters out the rest. And then if you see on the right, you will start seeing some dots appearing. Those are like the only time we invoke this function, so there's only one, but if this is called many times, then you will see lines. So you can define things like the order in which these metrics are shown. You can also define the period that these metrics are showing, so either 1 second of information, or 5 minutes, or 1 hour. And depending on that, you are going to see different things. The period and the statistics will make you see different things, so it's important that you tune your dashboard to something that you understand. So if I put 30 seconds, the average, it will be the average in 30 seconds, but I want the sum in 30 seconds, so it's a different value than the average. This case is the same because I only call it once, but if you have multiple. For some metrics, the average is good, for others, the sum is better. And then you have some graph options, you can put annotations, you can define what kind of data how you want to show the data. And that's kind of the graph. Then you can add numbers as graphs. That's something I like. Some things are easy to see as a number. So let's just look again for the same function, and then you can see if I change the period, then the average just disappears. There's not enough data. So now we have it 1 minute. And we don't have any data there. So in order to get some data, what I will do is I will trigger this function many times. So we can see in 1 minute, I don't know how many invocations we have. This takes a while. Usually CloudWatch is almost real time, so you need sometimes to wait a little bit. Now if I refresh this graph, you can see that there is some values, and we can see that there is some invocation. And also you can see now that we have called this couple of times. So if I change the period and I change the statistic, you start seeing things differently. So if I have the amount of, I don't know, invocations, in 1 minute there were 4, in 1 hour there's 8. So it's different values, so you can play a little bit with that. But always be careful on what is your period and what is your metric, because sometimes those numbers can be deceiving if you don't know what you're putting there. So another thing you can do is you can change the period that you're showing the data. So even if the metric is being displayed for every 30 seconds, you can also show what is happening in the last hour, in the last 3 hours, in the last day, or then you can show what happened in the last minute or in the last 15 minutes. And things like that. Remember that you need some data.
In this section, we are going to get started with Dynamo. Dynamo is a managed database from AWS. That means that you don't need to install anything and you don't need to maintain anything. AWS will do everything for you. You just put your data there and you can trust that the data will stay there and it will be available for you. So you don't need to worry about versions or updating the versions of Dynamo. You don't need to worry about patching the operating system where Dynamo is running. You just use the database. So it's pretty cool.
So let's start by providing a definition to what is DynamoDB. DynamoDB is a database service that was designed to support low latency and high throughput. Throughput is
in a database is how many transactions the database can handle before facing performance degradation because of its high workload. Basically, it means how many users can connect to the database and how it impacts the time to complete a transaction or to connect to it. Dynamo, as I said, is a managed database by AWS. This means that it's pretty easy to get started. You can forget all the problems that come with managing your own software, your database software and infrastructure, because Dynamo is not software, it's a service, and everything is handled for you. Dynamo scales automatically as your applications need it, and is a key value pair database and non-SQL. Let's go to the AWS console and create a table and see how this is done. So we are going to our AWS console, to the DynamoDB service, and there we are going to get started by creating a table. So we put the table name and then we put the ID for this table. You can pick if it's string, binary, and we will use all the defaults. And then you just pick create. And now you have your table, as easy as that. Now you can start using your table. In the first page, in the overview, you can see your table details, your name, what is the primary key, what is the other keys, and also you can see when it was created and what it has inside. And it doesn't have anything. We can create an item, we can call the ID test, and we can create it. And as it's a non-SQL database with no schema, we can add whatever we want, as many attributes as we want, and all the different items can be different, has different attributes. So now we have name, and now if we save another item with the same ID, it gives an error. So ID should be unique. That's one of the few restrictions that you have when saving to Dynamo table and item. Then we can check the metrics. There's nothing going on there because we have not really used this. Same with alarms. Then the capacities, the amount of reads and write units you can have simultaneously. If we change this to 1, now you can have 1 read unit and 1 write unit at the same time. And if you can see, the estimated cost will go down. This is all included in your free tier, so don't worry. If you're using this in production, you will be using the auto scaling, but that is not part of this video. So we can update this to 1. And then you have indexes if you need to query your data in more complex way, and you can have these global tables that is taking advantage of the global distribution of AWS. And there's other things like backups, triggers, access control, and tags that we are not getting into in this video. As I say, DynamoDB is a key value store that organizes the data in table. So each table contains items that are defined with keys. So the basic components of Dynamo are tables. DynamoDB doesn't have databases, it has tables. It stores data in tables. A table is a collection of data. Then it has items. Each table contains multiple items. An item is a group of attributes that is uniquely identifiable among other items. There is no limit of the amount of items per table. Each item in the table has a unique identifier or primary key that distinguishes the item from all the others in the table. Other than the primary key, the table is schemaless, which means that neither of the attributes nor the data needs to be defined beforehand. Then we have attributes. Each item is composed of one or more attributes. Each item can have its own distinct attributes. Most of the attributes are scalar, which means that they have only one value. Strings, numbers, binaries, these are common examples of scalar, but you can have nested attributes, and Dynamo has good support for them.
So now that we know the basics of Dynamo, let's go and create our own table using CloudFormation and store things in the database. We are going to perform basic operations in DynamoDB tables from Lambda using the AWS SDK. I will just go straight into the code and show you how you can get this done, building everything as infrastructure as code from the serverless framework. So let's go to the code. So let's get started as always, making a new directory and getting into the directory. We are calling this serverless Dynamo basic operations. And we get into the directory. Then we just initialize the npm package, npm init-yes, and then we initialize the serverless project
sls create -t aws-node.js-n, and then we put the name of the project, so that we don't need to change it in the serverless YAML. It's changed for us. Now we open Atom, and we are going to do some modifications, and then we are going to create our Dynamo table. So the first modification, we already have the name in place. I'm going to remove a lot of comments, they're distracting. Then I'm adding my profile because I have many, and I will just use my default profile. And I will pick the region that is Ireland, but you can pick any region you like. By default is North Virginia. Then we are going down in the serverless YAML, and we are just going to define the database using CloudFormation. I have done this many times, and basically we are defining a table, and we are using environmental variables, and I'm creating them in the serverless YAML so we can access them from the code and from the serverless YAML. So I create a custom variable, and then I add my environments property in the provider and refer to these custom settings that we just created. Then the next step is to define permissions for this table, and we are going to define the permissions where the IAM role comment is, and we're replacing it, and we're defining for get to put, update, and delete items in this table, so the Lambda can do that. And I will make one function per operation, one function for save, one function for get, one function for delete, and one function for update. After we have the 4 functions, I'm just going to save this file and go into the handler. And then here I'm going just to clean up a bit. We are going to create a function that will be generating our response, because we are just returning always a status code and a body, so why to repeat that everywhere. And then I'm going to create a new file that it will be the database manager, where I will be performing all the operations using the AWS SDK. So I create that file, I go into, and I will start defining all the functions. And here is the beef of this video. First thing we want to do is to require the AWS SDK and the module document client. Then I will define the table name as a constant in this module, and that's referring to the variable we have defined in the serverless YAML. And then I create the save function, the get function, the delete function, and the update function. And you will see that in each of these there is more or less the same structure. There is a parameters variable where we will define different things. In all the cases we have the table name, because we need to know in which table we are applying. In the case of save, we have the item, that is the one that we just want to save, the whole item, and the table name. In the case of get and delete, we have the table name, and also we have the item ID, that is the reference to this item we want either to get or to delete. For the update, let's stop for a moment and analyze the whole thing, because I think it's the most complex of all of them. So the update, it takes 3 parameters, the item ID, a parameter's name, parameter's value, and then it returns the new modify item. So the parameters that we need to construct this variable called parameters, the table name, as in our cases, the key, that is the item ID, and then it will take a set of other things. First, it will take a condition expression. This is not necessary, but I like to add it in the case. So if the attribute exists with this item ID, we can continue. If not, it will throw an error. The update expression. And here we define what is the parameters that we want to change. What is the attribute in the table we want to change. In this case, it's a flexible one, it's dynamic. So we pass that in the method, and I will put set params name, that will be whatever we decide to pass in this method, and it will be setting it to some value. The value is also dynamic, and you can find it in the expression attribute values that we define the dynamic value. And then we have the return values that we want to return all the new. You can change these for other options, either the old and all, new and old as well. You can check the documentation for the AWS SDK. And then after we have these 4 operations, we can go back to our handler and do the calls that we want to do from these operations. So we are going to create our 4 methods that are going to handle these functions. First, we want to generate the item ID. So for that, we need to use this library called UUID. So we just install it in our dependencies and then we can use it. I will use that in the save, so we have a dynamic item ID whenever we save, because in Dynamo items needs to be identified with a unique ID, so we should not have duplicates. So now I have the save item, and I will just fetch the item body that it will be passed in the API gateway body, in the request body, and then I'm attaching to that item that we get from the body the item ID that we are generating with this library, and then I'm passing that item to the database manager, that save item, and I'm returning in the callback the response with this item ID we just created and the 200. For the get item is similar. We are getting the item ID for the path parameters, and then we are passing that item ID to the database manager to the get item. And this item that we get, I'm returning it in the response to the API gateway so the client can see it. For delete, we have a similar one. We are getting the item ID from the path parameters, but we are just returning the item was deleted because the response in this case will be empty if everything goes fine. And here we are not handling errors, so in the case that the item is not fine, we are just not doing a catch. So that's something you need to handle in your case. For example, if you get an item that doesn't exist, it will return you an empty response because we are not handling the errors. So remember that these are only for the happy path, but this is an example for you to see. And for the update, it's a little bit more complex. We are getting the item ID from the path parameters, and then the param name and the param value from the body, because this will be a put, so we will have a body. And then we are passing those three things to our update item that will return the new item updated. And we will pass that back to our response. And that's all the code we need. Now we can go and deploy, and after this deploy, we can test it in Postman. So I will speed this up for you, so we go to testing. So when this is deployed, we get our 4 endpoints that are more or less the same. They just have different methods, and then we can take them to Postman and start playing with them. So we put our first one, that is the post, and we create a body that is very flexible because we have not defined anything. So we just pass whatever we want. I just pass a name, for example, and then we can pass some attribute 1, attribute 2, and things like that. This is an example, so it's not important what is in the item. Just imagine that you have something that makes sense for you. And then after we have this body, we can just send it and we will get an ID back. This ID we can use in the get. So we can now run the get. That is the same URL, but it has just a path parameter at the end. That is this ID that we just got. So I modify the call and I send it, and then we get the item back with the ID and all the attributes. We can update this item, and we are going to change some attribute. For example, attribute 1. We are going to change, and we are passing a new value for that attribute. And then we send it, and then we will see that the response now has this attribute 1 to be attribute 1 underscore new. So that changed. If we do a get again of this, we'll get exactly the same because this was saved in the database. Now we can do delete. If we just do delete, then the item was deleted, and then if we do a get, we are going to get an empty response because this is returning from the database an error, and we are not handling errors.
Congratulations, you make it! You finished the course! Yay! Now you should know more about serverless, and you will be able to get started practicing on your own and finding more information. If you want to know what next, I have some recommendations for you. First, stay tuned to my profile in Udemy because more courses are coming out. But if you don't want to wait, I recommend you to go to my YouTube channel where I have lots of free material for you to watch. Also, you can subscribe to my newsletter where I post different articles and bits of information that will keep you updated with the latest serverless trends and news and what is going on in AWS. So I'll leave you all the links in the related links of this list. Also, if you like this course, leave a review so other people can know how useful this course is and I can keep on improving it. If you have any questions or comments or things that you want to say to me, you can let them in the forum of this course, or you can contact me by the YouTube comments or my Twitter. I will leave the links as well for that. And now we are here, and I hope you had a great time watching this course. You learned a lot of things, and I hope to see you around. Bye bye!